A couple months ago, I released my Scene Manager for Godot, and I was kind of blown away by the response. A lot of you are already using it in your projects and, amazingly, spending real money for it on itch, where I'm giving it away for free. Thank you. If you're not familiar with it, here's the 10-second recap. The Scene Manager is an auto-loaded class designed to make switching between areas of your games super easy without having to build a full-on state machine. Pass in a couple of params and voila, everything is handled for you, including displaying transitions, loading statuses, and even passing data between those scenes. It's a simple solution to a common problem. Since its launch, the #1 request I've gotten is for more control over where your resources are added to the scene tree. Today, we're going to add that feature, along with a couple other upgrades, and do some much needed refactoring. If you're already using it, this will help you understand what's changed, and if you're new,
Son, your life is gonna get better. Starting now.
Version 1 favored ease of use over extensibility. All you had to do was give it the path to your scene, and you're done. You don't have to worry about what was being unloaded or where the new scene was going. Easy to use, easy to explain. This kind of system is great for clearly compartmentalized projects like arcade games that play out in one screen or puzzle games that bounce back and forth between level selection and gameplay. And while it does support more sprawling Zelda-like games, the all-or-nothing loading system can be limiting, but you gotta start somewhere, right? I had two main goals for this update. Move away from the old all-or-nothing loading method to one that allows you to target specific parts of the scene tree. The second goal was to decouple Scene Manager code from the game code. The original version mixed game logic with Scene Manager logic in far too many places. Scene Manager still does everything it did in the first version with a couple of upgrades, but of course with flexibility comes added responsibility. There's now a couple of places where you'll have to implement some logic that the Scene Manager used to handle for you, but I'm hoping when you see the new system you'll agree that a tiny bit of extra work is totally worth the trade-off. Alright, enough preamble, let's take a look at how to implement this into your game. Welcome everyone. Let's start by quickly reviewing what's in our demo here. So we've got our swipe transition, we've got our Zelda transition, we've got a fade to black and a fade to white. And all of these are initiated with one line of code from the Scene Manager. Those of you who have used the first version might notice that we've got this HUD floating here, which was not possible in the original version. So that's one of the things that we're going to cover today. Let's start by doing a 30-second overview of the flow of the Scene Manager internals. There's an awful lot of commenting in here, which I apologize is probably distracting, but it's using the auto documentation. And so when you download this from itch or GitHub or wherever, you're going to get a whole bunch of notes from me with some examples and yeah, there's a lot here. So that's why there's so much commenting. Sorry about that. When you initialize a transition, you pass in the requisite parameters. It adds a loading screen, which sends you into this load content function, which initializes the actual loading and starts a timer, which checks in on monitor load status every 1/10 of a second to see what's happening with our loaded asset. If there's a failure, you're going to get kicked into one of these errors, and when it succeeds, it drops us into this content finish loading method, which contains most of the new features. So here's the new data handoff implementation. Here's one of the new signals you can listen for, and we'll get to the rest of this later, but that's the gist. You send it a bunch of information on what you want to load, where you want to load it, and how you want to transition, and it does everything for you. And then once it drops into this, we can react to what's happening while it's happening. So this start screen is our main scene defined in Godot for this sample project. And this right here is the original signature for loading a scene. You pass it the path to the content you want to load, and optionally you define your transition, and that's it. The new signature and the new name swap scenes. And I changed the name because now the system assumes that you're always going to be swapping. You don't necessarily have to, and we'll get to that. But one of the new responsibilities with this architecture is that you tell it what you want to unload and where you want to put it, right? So we still have the path to what we want to load, and we're still defining the transition we want to use. But these two new arguments here, this first one is where we want to load it into, And this second one, or third argument overall, is what we want to unload. So in this case, we're saying when we click the start button, we want to load our gameplay scene. We want to load it into the root, and we want to unload ourself, which in this case is the start screen. So load this, remove this, use this transition. That's it. Which is why when we play this, if you take a look at our scene tree over here, we have our start screen. Here's our root. When I click start, we get the transition we requested. We've got our gameplay scene. And if you were watching, you saw the start screen disappear, which is exactly what we wanted. That's what we told it to do. So let's pop over to the gameplay scene, which is brand new to this sample project. This is a fairly common design pattern, I think. What we have here is a parent node that has some logic attached to it that's like your GameManager. So it's going to be managing some high-level stuff outside of the individual levels and content, perhaps. So this one's really simple. It's got a level holder, which does nothing but basically act as a folder for where the levels go, and our HUD, which is these hearts. So at the simplest level, now what we can do, rather than replacing this wholesale like we did in the original version, we're going to tell the scene manager to load stuff into this level holder node. I'm going to run this again, and if we pay attention to our scene tree, you'll see we get the gameplay, and we've got our level holder, which has level 1, and if I walk to the left, you'll see level 2 shows up and level 2 goes away. And that's one way to persist a HUD at the gameplay level. In the previous system, each of these level screens would have had to add the HUD, and then when you transition, that would get destroyed, and then the new level would add the HUD back, which is fine. Maybe not the most efficient way to do things, but also visually you would see it showing up and disappearing, which might not be the effect that you want. So this version is more flexible in that regard. But to take it a little bit further, so this gameplay scene, this like GameManager, is doing more than just allowing us to float a HUD above our levels. It's now assuming the responsibility of keeping track of the current level. And then we're going to use this current level variable to be able to tell it what to unload when we push a new level into it. And so that's one of the major features of this new scene manager, and a component of how we've decoupled the scene manager logic from the game logic. The way we're keeping track of these levels within our gameplay manager is by listening to this new load complete signal. If I pop over to the scene manager and scroll all the way to the bottom, right down here, this is the moment that everything's been loaded. We're guaranteed that the transition has completed. Everything's ready to go. We've even initialized our scene through this optional method, another thing we'll get to in a bit, and we're firing off this load complete. And so with the gameplay manager listening for that, when a level finishes loading, this thing fires and we're stuffing our level into current level. And this here is some logic that I'm implementing specifically because I only want to save information to this current level if it's in fact of type level. This is what all of my levels extend from. Because there's a possibility that when this fires, I might be doing something else with the scene manager, and if it's not a level, I don't want to save it here. But again, it's a little bit more responsibility, but it's also giving you way more control over how you react to different signals and different moments in the loading process. Before we talk about the rest of this gameplay scene, I want to pop over to our door scene. And actually, just as a quick recap, the way I've set up these levels is, so each level has got these doors at its exit, and the door defines the transition type, the direction of entry, a bunch of other things, including, of course, the path to the scene of the next level and the door in that level that we want to come through. So in this sample code, which again, this is not Scene Manager, this is just an example of how I'm implementing this in my game, sample game, is if we go back to the script and look at the door. So looking at this door class, when the player collides with it, we're going to access that current level variable from our gameplay node by, this is a little bit of a hack. In reality, you should probably be firing off a signal that gameplay is listening to because it's responsible for managing all this stuff. So the whole call down signal up rule. But to keep this example simple, I've done something that will totally work. It's not usually my design style. I've added my gameplay node as the only item in the gameplay group. So we can run a search for the first object in the gameplay group, which will only ever be this one thing. We're going to cast it to gameplay. Then we can use our reference to the gameplay node to access the current level variable that we've been tracking, stuff it in this unload variable, and then tell SceneManager to swap scenes. The new scene, which the door is storing, the path to the level holder, which is where we want to put it, unload the previous level, and use the transition that we've chosen on our door, in this case, Zelda. Make sense? Coming back into our gameplay scene, we are listening for two new signals. One is load start, which unsurprisingly starts the moment SceneManager begins loading something, and scene added, which happens the moment after something has been added to the scene tree. And these are helpful because they allow us to control the scene tree without having to touch the SceneManager code. So we are already now targeting where we want to put it. But so let's say, for example, we wanted to target the gameplay node instead of this level holder. If we remove that reference and target the gameplay node, you'll see when we transition screens and expand our gameplay, now we've got level 2 here, HUD here, level holder's just hanging out, it's empty, whatever. We could have deleted it. But now we have the problem that level 2 is above our HUD and we're not seeing our HUD. Well, that's where these signals come in super handy. So in order to fix that, in our onLevelAdded function, which fires the moment after our level is added to the scene tree, we can move the child to child count -1, which basically just says put it at the top of the parent. So now with this uncommented, when I transition, the HUD stays on top, and look, level is still a sibling of HUD, but it is below the HUD, which is what we want. And you'll notice I'm already doing that right here with the loading screen, which gets added before the level gets added to the scene tree. So if I were to comment this out, what you would see, and I'm going to use a different transition. Actually, you can see it right there. So you saw the wipe to the right, but then at the midway point, you didn't get the rest of the animation from left to right. You just got this in place. The level was effectively just slapped on top of the second half of that transition. So by doing the same sort of trick, we're grabbing that loading screen and making sure it stays on top of the level because we want the level to be revealed underneath it. We can do all of that by listening to this level added signal, which passes a reference to both the level, which is the thing we've loaded, and the loading screen added by SceneManager, and which removes itself at the end of the loading process. And then it gives you full control over the scene tree. You just have to implement the logic you're looking for. And there's also, like I said, a signal that happens right after the loading begins, which might be an instance where you want to move, say, the HUD above the loading screen while that's playing or whatever. We're not going to get into that here. And now if that's the way I want to manage things, I don't even need level holder. I could move level outside of it. I can delete this. And of course, now that we're responsible for managing all of this stuff, we're going to have to make a change here because on initialization, I'm storing a reference to that first level because remember, we're going to use it to figure out what we're unloading later. So now in gameplay, this has to change. And, instead of level holder.getChild at 0, I could do something like, and now on startup, we're storing that in current level, which is just an initialization thing. Of course, everything else moving forward, the tracking of current level will still be managed by this. What is this angry message? Oh, right. If we delete that, then this is no longer relevant. All right, so I don't love this as a design choice because this level might change. I might rename it. I might be loading this from saved data, but for the purposes of this example, That just sort of demonstrates how we're initializing our current level and how that's relevant to our scene tree. So those are the 3 new signals in SceneManager that will allow you to execute logic at 3 different points in the SceneManager's loading process. The next thing I want to look at is some optional methods that loaded scenes can implement in order to further inject some logic into the SceneManager without having to touch the SceneManager code at all. Of course, you're welcome to if you want to further customize it, build on top of it. But for those of you who just want to use it out of the box, you can get a lot of functionality out of it just by leveraging these 4 new optional methods. So let me come down into our SceneManager and let's look at this on content finish loading. This is the last stop in the chain of logic in our SceneManager. And the first thing that we do here is we're going to check the incoming scene on the outgoing scene. This is the thing we're unloading. This is the thing we're loading. And if the scene we're unloading implements this get data method, meaning it has data to pass along to the next thing that we're loading, and the new scene implements this receive data method, that means they might actually have something they want to pass between each other. And if so, we're going to pass the get data, whatever this returns, to our receive data. And I'm going to show you how I'm implementing that in my levels. So every level in this game extends from this level class. And up top here, let me hide all this other stuff for right now. All we want to look at right now is this get data method and this receive data method. So the get data is very straightforward. It just returns whatever data we've packed into our level data handoff structure. And actually, you can see that right here. So when the player enters the door, I'm packaging up everything that I want the levels to pass between each other inside this data function. SceneManager begins loading it, and at some point, SceneManager is going to request it if get data is implemented. If it's not, it'll just skip, which is exactly what we want. Now, if the level that we're looking at is being loaded rather than unloaded, then it's going to look for this receive data method, again, optionally implemented. It's going to receive this from the previous level. And, this is all internal logic. And this is where you can do a whole bunch of stuff that is completely independent of the SceneManager. So in my case, I know that the only data I ever want a level to receive is going to take this level data handout format. So I'm going to run that check first. And if it is, I'm just going to store that data because I know what I'm going to do with it later. If it's not, I'm throwing a warning here just in case. I want to be notified that, there was a data mismatch. But the system is designed for there to be data mismatches. The system is also designed to allow you to write different logic depending on which scene is talking to which scene. So for example, levels are always going to pass this level data handoff between each other. That's just what they do. But let's pretend, for example, you had like a character selection screen that was between the start screen and the first level. Granted, you would probably be storing whatever the player selected in like a preferences file or something. But just to exemplify this, you could have another check that is like if, data is, let's just say down here, you might say, L if data is character selection, meaning it's of that type. And meaning that the only situation, this is throwing an error because this doesn't exist, but this situation would only occur if your scene selection screen has a get data method that, passes characters. Says section selection. Your data selection scene, which is moving through the SceneManager, implements this get data and returns this. And if the receiving scene, in this case, the first level that's loaded maybe, is prepared to do something with that. You can implement certain logic when it's a level talking to a level, and then you could implement other logic. This is so wrong.
It's my birthday!
And then you could implement some other logic, say set character data or whatever, in the instance where a level selection screen is talking to a level. And in any other combination, this will all fail silently because you're accounting for 2 levels talking to each other or a level selection screen talking to a level. This is how we create separation between church and state, keeping SceneManager logic in the scene, and then letting anything that's going to pass through the SceneManager to implement the logic that it needs when it receives or sends data. I hope that makes sense. So those are the first two optional methods that any two scenes loaded through the SceneManager can implement. Get data, receive data, pass it between them. Much better than the previous implementation, which was checking if is type level, and then it was doing some stuff which worked for my sample game, but wouldn't work if you don't have a level class in your game. And why should you? So this duck typing option that Godot can sometimes lean fairly heavily into is perfect for this kind of generic implementation. The last two I want to look at is these init scene and this start scene method, which again, totally optional. So init scene and start scene are called almost back to back. The only thing that sits in between them is your transition finishing. But the way I'm using them is when I start loading a new level, I turn off player input. So the player can't run around while transitions are happening. And before that animation finishes, I want to move the location of the player, but I don't want to give control back. So if you look at our scenes, you'll remember we set them up in a way that allows us to jump right in and test the scene directly without having to go through the start screen and all of that. And what that means is the default start location in all of my levels has nothing to do with a door. So when a transition begins, I'm hiding the player. I'm reading the data handed off between levels, which tells me where I need to put the player. So I want to be able to set all of that up before I give the control back to the player, and ideally before the player sees the new scene. So that can happen before the transition completes, and then when the transition completes, then I can give player control back. So if we look at the way the level is implementing these, you'll see in the init scene, the only thing I'm doing is initializing the player location. So I'm looking at the door that it came through, the direction I'm moving, and I'm setting all of that up. And then at start scene, when everything is totally done, I'm giving control back to the player and I'm connecting to the door signals in that room because we don't want the player to be able to accidentally wander into anything before the loading is complete, before the transition is complete. So you'll see when we test this, when I go into this next room, the player is in the right spot. He's facing the correct direction. So that's one way you can use these two init and start scene methods. You can optionally implement them to give you an opportunity to set things up. And then this would be, for example, I don't have enemies in this sample of game, but if you look at the original Zelda game, when you enter a room, there's like no enemies in it, but then the enemies spawn and start moving around. So inside this start scene, maybe in a init scene, you're getting some information from the previous room that is relevant to what you're going to generate in that room. So you get that information here and receive data. Maybe you process some of the setup in init. And then when the transition is completely done, then you tell the level, okay, spawn your enemies, set up items in crates or whatever. And you don't have to implement both, but it was easy enough to put them both there. So I figured, why not give you the option? So with these 4 new optional methods to implement and these 3 new signals, you actually have a tremendous amount of control over what happens and when without having to touch the SceneManager code at all. So ideally, you can reuse this in multiple projects, change the logic, and just drop this in wholesale. And, as a reminder, all of this is exhaustively documented with all these ridiculous comments that are in here. And if you want to get to that documentation, you can simply search for SceneManager, and it will take you to this file right within Godot. The last thing I want to cover is briefly how the Zelda transition initialization works. It's very slightly different, and it's changed a little bit. In the original version, I had 2 copies of this on content finished loading method, and there was a lot of code duplicated, and a lot of that code, again, was very specific to the game using it. In this version, I've combined them, and then the only thing different is that there's this Zelda block in between that executes only for the Zelda transition. I don't truthfully love this implementation. I would rather everything execute transitions in exactly the same way, but you have to learn to kind of cut a version off when it works, and then maybe in the next version I will implement this differently. Since the Zelda transition doesn't actually use the transitions in our animation player, it tweens stuff around. The method that I landed on for this version looks for that transition, it executes this stuff, it waits for it to finish, and then it just continues along with the same logic. All the same optional methods work exactly as described. The only difference is that when you want to use this swap Zelda scene, you're not giving it a transition type because it's already setting that statically here. So instead of that transition type, you're specifying the direction. Moving left, moving right, moving up, moving down. And, on that note, another thing that I chose not to build into this version is it doesn't account for levels that are different size. So all the levels in this game are 144 by 240. If you're making a game that also has levels that are all the same size, you'll just need to edit this. And frankly, you'll probably want to put this information somewhere besides the scene manager, but again, stubbed in for simplicity in this example. In future versions, I might build it to accept the size of the incoming and outgoing level and adjust, the starting positions and the ending positions as a result. But I want to make these updates in bite-sized pieces, and I don't want to overcomplicate it more than I have to. That is the gist of how to implement Scene Manager in your game. A couple of things to note. One, if you haven't watched the first video, there are some things in there that I'm not covering here because I've already covered them. For example, the first video will show you how to add your own transitions, and that process hasn't changed at all. So if you want to do that, create additional transitions specific to your game, go check out the original. I will link it up here. The last couple of things I want to say here is this system is designed for a specific need that I had, which was largely, I want to very quickly and easily be able to transition between a start screen and my game, and the game over, or a level and a level. This isn't designed to rapidly load parts of your game in sequence. In fact, you'll see that even though this leverages the resource loader, which can handle multiple concurrent threaded processes, I'm actually looking for this loading in progress flag before we start loading and just dumping out if we're already in the middle of something, because it would dramatically overcomplicate this class to keep track of multiple things being loaded and allow you to make calls to loading stuff through the scene manager in rapid succession. So this is designed to just bail out if it's already loading something. In future versions, that might change, but because my use case was I just want to bop between major areas of my game, this is a limitation I was willing to accept. Believe it or not, despite that, if we pop over to the start screen, I do have an example here real quick. You can just load a thing and not unload something else. It is designed to do that, and you can do that by passing null into unload. But I want to show you this real quick. This is another limitation, but again, it's a thing that I design around. If I run this, it's going to throw an error, because what's going to happen is the scene manager, I'm trying to run the scene manager, which will add something to the scene tree while we're still in our onReady function. And the scene tree is still in the middle of building itself. So a way around that is, if you want to use it that way, you can defer the call, which will wait till everything is set up, and then it will call this. And so I'm going to show two examples, right? One is the deferred call to get around this limitation. I frankly would just not call this in ready. I would make it an active call. So something that it's only executing when you know it's the right time to actually swap scenes. But this is going to demonstrate the call deferral, which will remove this. But then it's also going to show you this null. So I'm actually going to run this, and it's going to load the player on top of the start screen and not remove the start screen. So there it is. So you could use this in your game to load things into a scene without having to replace or unload something else. But I built that feature in because it was a fairly easy thing to add. I can't think of great use cases for it because frankly, if that's something you're doing, you're probably going to do that through the built-in methods for loading and instantiating stuff and adding it to your scene. But it is there, and it does demonstrate this call deferral and the limitation of, when and how you decide as a designer to execute a scene swap or a Zelda swap or whatever. I think the final thought I want to leave you with is that I banged my head against this for about a week, trying to figure out how I wanted to architecture things, and I tried a whole bunch of different ways. And the truth of it is, I was getting in my way because I was trying to make it do too many things for you. I wanted it to just work. And in a way it does, but I was trying to do that without asking much of you. And the trade-off for that, of course, is I end up coding you into a corner, because if you want to use this thing, this is the exact way you use it. And of course, there are some trade-offs like I just mentioned, but I guess the point I'm trying to make is, if you're really struggling to design a system for yourself, it might be that you're just asking too much of the system. Maybe the system is too big and you need to break it down into component parts. Maybe you just have unrealistic expectations for what your code can or should do. And it can be very easy to think that, this is the right technical way to do a thing, and try to over abstract your code, account for everything. But a lot of times when you take that approach, more often than not, and at least in my case, I would just give up on a thing because I would ask way too much of myself, way too much of my code. And, it makes me think of this thing my buddy Rick says all the time: perfect is the enemy of good. And most of the time when you're writing something, it doesn't have to pre-account for every situation you or anyone else will ever use it in. Sometimes functional is enough. Sometimes building just the features you need is enough. And all of the time, you can take that approach, ship a thing, work with it for a little while, and learn that, hey, I made the right choice, or I made 80% of the right choice. Let me finesse that final 20%. It's better to finish a thing and make it work than to give up on it because you're trying to ask too much of yourself or your code. And to that end, one of the things this version of the code is going to allow me to do, I don't know if any of you have watched my GitHub video on how to set up a project template. This is going to be the first commit into my personal repo, which I'm going to share with everybody. I'm going to add a few other things like some menu screens and some player preference and volume savings, stuff that I need in every game. And I'm of course going to continue to still make these one-off tutorials on how to do a certain specific thing, but I also want to add to the channel this loop of commit a version of my game shell to a repo, do a video about that so you know what the new features are and how to use them. That repo will be freely available for all of you to use. And then I'm going to make a small game with the current state of that repo, and I will probably make a game about some of the coding choices I made. I will probably make the source code to that game available in some format. And then in that process, I will certainly find new features that I want to be in my repo, and I might learn, having field tested, some things I want to change about what's in that repo. So coming out of a small game based on the current version of the repo, that's going to give me features and updates to add to the repo, which will go back into the repo, and the loop will repeat. So ideally, over time, we get a bunch of content to look at. We can look at some coding and design strategies, but along the way, we're going to build a repo together. We're going to learn how to use it, and I'm going to make that available to all of you. So if that excites you, if that interests you, definitely subscribe and keep an eye out for updates to the repo and new games and all of that stuff. I think that's going to be a big part of the channel moving forward. We'll see. Maybe people hate it and maybe I'll stop doing it, or maybe I'll stop talking about it. I probably won't stop doing it. The purpose of learning and growing my code library in Godot is I want to get back to making more games. And I want to help as many of you as I can in the process. Yeah, let's kick it to the outro. So that's the gist. I hope you like it. I hope it makes your life easier. And if it does, or if it doesn't, either way, leave a comment down below, get into the conversation. Source code for the old SceneManager and the new one are available on both itch and GitHub, free to use without attribution. I hope you like it. If you have feature requests, please let me know. In the meantime, please be kind to yourself, be kind to others, and I will see you in the next video.